heptapartitioned neutrosophic sets. Well, let us recall some basic facts about fuzziness. Fuzzy set, introduced by Radha in 1965, is based on the idea that we can measure the degree of membership of the elements of universe to the fuzzy set A. In intuitionistic fuzzy sets defined by Atanasov in 1983, we have degree of membership and degree of non-membership, which do not have to sum up to 1, although their sum should not be greater than 1. Then we have neutrosophic sets of Smarandaja, which are equipped with 3 functions of membership, non-membership, and indeterminacy. In case of quadripartitioned neutrosophic sets studied by Chatterjee Majumdar and Samantha in 2016, this indeterminacy has been decomposed into 2 functions, the one of contradiction and the one of unknownness. In 2020, Malik and Pramanik have introduced pentapartitioned neutrosophic sets where you have also ignorance function or measure, so you have 5 components. In 2021, Radha and Stanis Arul Mary have refined heptapartitioned neutrosophic set. They studied basic properties of the structures and they sketched possible ways of further studies. This presentation is essentially based on their paper. Well, let R be an unempty universe. An HNS heptapartitioned neutrosophic set over R characterizes each element small r in capital R by the functions listed below. We have absolute truth membership, relative truth membership, contradiction, unknown, ignorance membership, relative falsity membership, and absolute falsity membership. TMCUIKF. TMCUIKF. And of course, we assume that each of these functions has values between 0 and 1, including maybe 0 and 1, and so their values sum up to the number not bigger than 1 and not smaller than 0. In general, each heptapartitioned set A can be written in the following form. As you can see here, this is clear. TMCUIKF. Well, according to our authors, a heptapartitioned set A is called an absolute A in just delta, even only if it satisfies the following properties for any R in R. Truth, absolute truth 1, relative truth 1, contradiction 1, unknown 0, ignorance 0, relative falsity 0, falsity 0, 1, 1, 1, 0, 0, 0, 0. In case of so-called relative, or in some sense empty, H and S, we have 0, 0, 0, and then 1, 1, 1, 1. Now assume that both A and B are heptapartitioned sets on R. We say that A is contained in B even only if, for any R, absolute truth is not bigger than absolute truth of B. The same with M and C. And here we have inverted situation. Unknown A is greater or equal to unknown B. I is greater or equal than IB. KA is greater or equal than KB. And the same with absolute falsity. A complement of A and S, H and S, is denoted by AC and defined in the following manner. As you can see, absolute truth and falsity have been mutually replaced, the same with relative truth and falsity, and with ignorance and contradiction, and in case of unknown we have 1 minus unknown A of R. As for the union of two heptapartitioned sets denoted by A, well, union operator B, and its functions are defined in the following way. Maximum, maximum, maximum in case of T, M, and C, and then minimum, 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 minimum in case of U, I, K, and F. Max, 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 min, 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 min. In case of intersection, that is A and B, we have min, 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 max, 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 max. We may consider this example its simplified version of the example presented by Radha and Stanis in their paper. They used a universe with 3 elements. We used only 2, namely A and B. And here's our heptapartition set A. Now, its functions for element A and for element B. And here's our heptapartition set B. Its functions for A and B. And here we have union and intersection. For example, in case of union for small a, we have maximum of 0.5 and 0.9, that is 0.9, maximum of 0.6 and 0.8, that is 0.8, maximum of 0.2 and 0.9, that is 0.9, and then we have minimum of, for example, 0.4 and 0.7 is 0.4, 0.2 and 0.1 it's 0.1, 0706 is 06, 0305 is 03. And you may check the rest of our calculations. Yes, you may also find complements of A and B. And perhaps it's not so much surprising that the algebra of heptapartitioned neutrosophic sets on R satisfies the following well-known Boolean properties, like commutativity of both operations, associativity, distributivity of both operations, absorption, involution, contradiction, and finally De Morgan's laws. And if you are interested, then these properties were proved in detail in the original paper of our authors. And this is the bibliography. This is this original paper of Radha and Stanis Arul, and these are papers on pentapartitioned and quadripartitioned neutrosophic sets. Thank you very much for your attention.